All right. So the first question asks us to multiply 3 minus 2i times 3 plus 2i. These are two what we call complex numbers. Remember, the 3 is the real part, the negative 2i in this case is the imaginary part. The combination of a real number and an imaginary number is what we call a complex number. And these two complex numbers that we want to multiply happen to be conjugates because they're identical binomials except one has a minus and one has a plus. So therefore, we don't have to do the whole FOIL. Usually when we multiply, we use the whole FOIL. Now we can get away with just doing first and last because with conjugates, the inner and the outer terms always cancel out. So 3 times 3 will give me 9. And negative 2i times positive 2i will give me negative 4i squared. And remember, our I squared is always replaced with my negative 1 because I squared is the real number negative 1. I is the square root of negative 1. I squared is negative 1 itself. So this is negative 4 times negative 1, which becomes a plus 4. And 9 plus 4 gives me 13. So the answer to this was 13. Any question about that? I hope most of you got that answer. So this is what's called multiplying of complex numbers. As again, they're not always going to be conjugates. If they're not conjugates, you do the whole FOIL. Again, the important thing is when you come across I squared, you replace it with negative 1. Right, the second question is a division or a fraction, 3i over 3i plus 2. And when we have a fraction with i's in it, simplifying or dividing it consists of making sure that your final answer does not have any I in the denominator. It's another way of saying rationalize the denominator. And we do that by looking, if it's a single term, if it's just a 3i, then we just multiply top and bottom by I. But if our denominator is a binomial, as it is in this case, then we have to multiply by the conjugate of the denominator, which would be, in this case, 3i minus 2. As we've seen before when we did this example, when you multiply conjugate by complex binomials, your final answer comes out to be just a plain real number. There's no I in the answers, and that's what we're trying to get. Of course, since we're multiplying the denominator by 3i minus 2, we've got to do the same thing to the numerator so that we end up just multiplying by 1. Okay, and as you, if you've seen me do this before, you know I always like to do the denominator first. So 3i plus 2 times 3i minus 2. Again, these are conjugates. I just have to do first and last. 3i times 3i is 9i squared. 2 times negative 2 is negative 4. This makes this a negative 1. So therefore, in my denominator, I end up with negative 9 minus 4, which is negative 13. My denominator turns out to be the real number, negative 13. In the numerator, I have a 3i times a 3i minus 2. In other words, I'm going to have to use the distributive property because I have a single term times a binomial. So first I do the 3i times the 3i, which gives me 9i squared. And then I do the 3i times negative 2, which is negative 6i. Don't forget, you have to multiply it, the 3i, by both terms. And again, this is our negative 1. So this becomes 9 times -1, which is -9 minus 6i. Okay. All right. Now, usually what we do with these is we put them what's called in a plus bi form. That means we take each, if there's a denominator, we put each term from the numerator over that denominator. So I'll separate it and I'll do -9 over -13 minus 6i over -13. And of course, when I see a negative over negative, it becomes a positive. So that's 9 over 13. Again, this is a negative over a negative. I'm subtracting and I'm dividing by a negative. I have two negatives, it becomes a positive. So this becomes 6i over 13. And this would be our answer in what we call a plus bi form. And that's usually the way they want it to be given. You could have, of course, just left it like this, but usually we don't leave a negative in the denominator. So if I see a negative in the denominator, I'm going to multiply both the top and the bottom by -1. If you didn't do this, you could have done this. So this would have given you on top, -1 times -9 times -6i is +9 plus 6i, and negative times negative is again 13. Again, do not leave a negative in the denominator. So either answer is acceptable. Again, usually the answer is what left in what we call this a plus bi form, where we separate the real number and the imaginary part. So that would be the way you would do these. And this is what we reviewed last time. So now we're going to go on, since we know now how to change things into i's. When we have a square root inside a negative, we know we're going to make it into an I example. We know how to add, subtract, multiply, and divide expressions with I in them, or what we call complex numbers, which takes us to the end of chapter 6. Next week on Tuesday, I will announce when you should be looking for your test on chapters 5 and 6 on Delta Math. The next test is going to be on Delta Math. It'll be the 5th test we have taken this year term. There have already been 2 on Delta Math, and there have been 2 on Blackboard. One was the practice test midterm, and one was the actual midterm. So we've had a total of, so far, 4 tests. We're going to go on to our 5th test, which is going to be on Delta Math. In the interim, we are starting chapter 7. Again, I will tell you exactly in terms of the exact times when to look for that test, but in the interim, you should be finishing up your homeworks on that we've been doing on chapters 5 and 6. I will email you exactly which of the homeworks on Delta Math apply to chapters 5 and 6. And all the work we've been doing in the last couple of chapters really are preparations for us to be able to do one of the most important things that you learn this term, which is to solve quadratic equations. And a quadratic equation is some kind of equation where we have a x squared, or if our variable is x, in the equation. In other words, another way of saying a quadratic equation is to say it's a second degree equation. The degree is the highest exponent you see. And in a quadratic equation, you're going to see an exponent of 2. Now, we did do a couple of examples that also had exponents of 3, but they were just a little bit of a step further. We're going to concentrate on this quadratic equation, this exponent of 2. Now, you're going to say, we already studied that. We did that. Yes, we did. We did examples. For example, if I gave you something like this, x squared minus 5x equals 24. Suppose I gave you this. This is obviously a quadratic equation. It has an x squared in it. So we know it's a quadratic equation. And if I'll remind you how we solved it. We solved it by bringing the number to the other side so that we had everything on one side and the 0 on the other side. So I will bring the 24 over to the other side of the equation. This will give me x squared minus 5x minus 24 equal to 0. And then I factored this. This is not anything new. We've done this before. We did x and x. The fact that the last term is negative means one sign is going to be positive and one's going to be negative. And we look for two numbers that multiply to 24. And when we subtract them, we get 8. And those numbers are 8 and 3. And the 8 is going to have to be the negative one because the middle term is negative and the 3 is the positive. And then we set each one equal to 0. So one answer we got was x equal to negative 3. And then we did x minus 8 equal to 0. And that gave me x equal to 8. And I got my two answers, negative 3 and 8. And this is something you might have learned in an earlier course, but certainly that something we've already done in Math 136. We started the term doing linear equations, those exponents, and then we talked about quadratic equations. But the problem is that this method doesn't take care of all possible quadratic equations. What if I give you an equation that's not factorable? What do you do when this whole method depends on being able to factor if, number one, you don't know how to factor it? It might be factorable, but you don't know how to do it. Or number two, it isn't factorable at all. There are examples that are not factorable. So that's what we're going to be doing in Chapter 7. We're going to be dealing with quadratic equations, and we're going to learn basically two methods that can be used to solve any quadratic equation, whether it's factorable or not factorable. Any quadratic equation will be able to be solved once we finish Chapter 7. Obviously, this is an extremely important chapter because the one thing that you really have to know going into any other math course is how to solve an equation. you know how to solve linear equations. You know how to solve equations that don't have exponents. But how do you solve a quadratic equation? And that's something you have to walk out of this course knowing cold. So let's look. I'm going to do this in steps. Let's look at some different types of methods that can be used to deal with quadratic equations. Now, the first method that we're going to talk about is something called the square root method. The square root method can only be used in what we have if what we have is what's called an incomplete quadratic equation. What if we have a quadratic equation that looks something like this? X squared equals 9. Or if we bring the 9 to the other side, so it's like a standard quadratic equation equal to 0, we get x squared minus 9 equals 0. Now, it's obviously a quadratic equation because it has an x squared. And therefore, we set it equal to 0. Because that's what we're supposed to do with quadratic equations. It's called incomplete because it's not a trinomial. We don't have 3 terms. We only have 2 terms. We have an x squared terms and we just have a number. We don't have that middle term, that x term. Okay, how do we solve this quadratic equation? Well, we know how to do this. We factor, just like we did before. X squared minus 9 is x plus 3 times x minus 3. This is called the difference of squares. So we get the 2 binomial conjugates. And then I do x plus 3 equal to 0, which gives me x equals negative 3. And I also do x minus 3 equal to 0. And that gives me x equals 3. In other words, I can solve this quadratic equation by my factoring method and what we got were 2 answers, negative 3 and 3. Sometimes you'll see that answer written with a plus over a minus 3. If you see this funny symbol, a plus on top of a minus, it's because we're a little bit lazy to write. It means one answer is plus 3 and one answer is negative 3. Instead of having to write the 3 twice, I just write it once. And you understand the plus over minus means there are 2 answers, one being a positive answer and one being the negative answer. Well, we were certainly able to solve that, but we could have solved this in a much quicker method. Let's look at our original equation, our x squared equals 9. Now, if I tell you x squared equals 9, I think most people would say, oh, I know what x is. What number do I multiply by itself to give me 9? Obviously, it's 3. But it could also be negative 3 because negative 3 equals times itself. When you square negative 3, it'll also give you 9. So with literally almost no work, I could have come up with the answer being plus or minus 3. In other words, if I have x squared equaling some number, I'll call it n or number, then we can solve this by just doing the square root method. X will be plus or minus the square root of whatever that number is. In other words, if x squared equals 9, then x will have to be plus or minus the square root of 9, which means that x equals plus or minus 3. A lot less work, a lot quicker. Saves us some time. Also allows us to solve a lot of different types of equations. Equations that we couldn't have solved before. For example, what if my question had been x squared minus 7 equals 0? And I said, solve that. Now, that's a problem. Why? Because this is not the difference of squares. 7 is not a perfect square. I cannot factor this, but I have this square root method that I can use. Bring the 7 to the other side. That'll give me x squared equals 7. So now we have x squared equals a number. So using the square root method, we get x equals plus or minus the square root of 7. Actually, my answer turns out to be an irrational number. Square root of 7 is not rational. It's not a number that is a perfect square, 7. So, but we do have an answer to this question. So even if, here's a case where we had something that was not factorable, we still were able to solve it using the square root method. If I had had something like this, x squared plus 25 equals 0. Now, x squared plus 25 can't be factored. Even though x, this is a perfect square, x times x, and this is a perfect square, 5 times 5, the sign between them is a plus. It's not the difference of squares, it's the sum of two squares, and it's not factorable. The only two terms that are factorable are when you have the difference of squares. If you have this is a square, and this is a square, and there's a minus in between them. Otherwise, you can't factor it. But we can use our square root method. Get the x squared to the 25 to the other side. That will give me x squared equals negative 25, which means that x has to equal, I have x squared equals a number. So x squared has to be plus or minus the square root of that number, that negative 25. We just learned how to deal with the square roots of negative numbers. This really means 25 times negative 1. So that's equal to plus or minus, here's my plus or minus, square root of 25, which is 5, square root of negative 1, which is 5i. In other words, in this case, in the first case, we got an answer that was an irrational number. In this case, we get an imaginary number as our answer, 5i and negative 5i. But notice, none of these were very difficult to do because we could use our square root method. Now, I can use this square root method even in more complicated situations. Suppose I have a question like this. Suppose I have something that says x minus 2 squared equals 16. I'm going to show you a long method to do this, and then I'm going to show you a short method. Obviously, if both methods give you the same exact answer, I think everybody would prefer using the short method rather than the long method. So let's look at, I'm going to erase this because we already have this. My normal, until I started this chapter, if I gave you something like this, I think everybody would say, well, the first thing we better do is get rid of the parentheses. In other words, we have x minus 2 squared, which means x minus 2 times x minus 2, which will give us x times x, which is x squared. Outer is negative 2x. Inner is negative 2x. And last is negative 2 times negative 2, which is positive 4. Or if we put everything together, x squared minus 4x plus 4. Actually, I'm going to show you right now how I could have done that. I see there's a pattern here. When I have a binomial squared, and we're going to be doing this quite a bit, so we may have look at the pattern, because we have the pattern, we can do it much quicker. If you notice, if we want to square this binomial x minus 2, my first term is squared, x times x. It gives me x squared. My last term is the negative 2 times negative 2, the positive 4. In other words, I square the first term to get the first term. I square the second term to get the last term. But how do I get that middle term? Where did this negative 4x come from? Well, if I multiply these two things together, the two terms that are inside the parentheses, the x times the negative 2, I get negative 2x. Now, if you think about it, I'm really doing negative 2x twice. So take that negative 2x and multiply by 2. That gives you negative 4x. Before I go on, let's just do another one like this. Suppose I had x plus 7 squared. I'm going to show you the quick way of doing this. Of course, I could do it by FOIL. I could do it x plus 7 times x plus 7. But if I want to do it the short way, I just remember the pattern. There are going to be 3 terms. The first term is going to be the x times the x, which is the x squared. The last term, the third term, is going to be the 7 times the 7, which is plus 49. And how do I get the middle term? I take these two terms, the x and the 7, and multiply them. So that's 7x. And double it. Double the two terms together. That'll give me 14x. As a matter of fact, I could use that. If I had given you x squared plus 14x plus 49, I could see that this is a binomial squared. How can I see that? Because the first number, x squared, is a perfect square. It's x times x. The last number is a perfect square. 49 is 7 times 7. And the middle term is the combination, the 7 and the x that I got multiplied twice. 7, I take the square root of this is x, the square root of this is 7. 7x times 2 gives me the 14x. That is the pattern. So if I look at the pattern, then I can do this squaring or unsquaring pretty quickly. Okay, let's see if you can do this before I go on to that problem. Suppose I gave you x minus 5, and I ask you to square it. I'm giving you a minute to try it. You really should be able to do with the pattern this very quickly. Okay, I think we should do it together now quickly and remember the procedure. The x minus 5 binomial squared means we're going to end up with three terms. The first term is going to be the x times the x, which is going to give me the x squared. The last term is going to be the -5 times the -5, which is plus 25. And whenever you're squaring something, your last term will always be a positive number. And your middle term, well, you multiply these two things together. 5 times -x is -5x. But I have to double it, remember, because I'm really doing that twice when I'm multiplying one by the other. So -5x times 2 is -10x. And that's what you would, how you would do that squaring process very quickly. Great. Thank you, Carmelita. You actually got it. Okay, so let's go back. So we're going to remember this quick way of squaring binomials. It may come in handy a little bit later on. But let's go back to this problem. So we did the x minus 2 squared, which gave us x squared. X times x is x squared. The last term is -2 times -2, which is 4. And this is -2x times 2 is -4x. That's going to be equal to 16. And now I see it's my quadratic equation. I want to get it equal to 0, so I'll subtract 16 from both sides, which will give me x squared minus 4x minus 12, because 4 minus 16 is -12. And when I factor this, hopefully it's factorable, I get x and x. The last term is negative, means one is positive and one is negative. And I need two numbers that multiply to 12, but when I subtract them, will give me 4. Obviously, that's 6 and 2. And the larger number, the 6, will be the negative because the middle term is negative and the middle term is positive. So that we end up with x plus 2 equaling to 0, which gives me x equaling to -2 when I bring it to the other side. And x minus 6 equal to 0, which gives me x equal to 6. So the solution to this problem turned out to be -2 and +6. Now, I'm going to show you a much quicker way to do this. And I'm going to show you that what we're going to get is the exact same answers, which is, of course, if you get the wrong answers, it's not going to help you. I'm going to show you using the square root method that we talked about before, how we could have solved this equation. And I hope you'll realize how much time it can save you if you know how to do this. This is something squared. It's not just a plain x squared, it's x minus 2 squared. But what I'm going to do is I'm going to take the square root of both sides. Whenever I have something, a variable or combination of variables, squared equaling a number, I can take the square root. Now, when we take the square root of x minus 2 squared, that'll just give me the x minus 2. The square root of something squared is just what's the item. On the other side, this is not something squared, so I actually have to do the square root. I have to do plus or minus the square root of 16. Remember, that's exactly what we did when we had x squared equal to 9. If we had x squared equal to 9, remember, then we did x equals plus or minus the square root of 9. So I'm actually doing the exact same thing. The only thing is, this is not just x, it's x minus 2 squared. Okay, but now I can finish this. This gives me x minus 2 equals, well, the square root of 16 is 4, plus or minus 4. But I want to know what x is. I don't want to know what x minus 2 is. So in order to get x, let me bring this 2 to the other side. Add 2 to both sides. Now, when I do this, I want to put the 2 first rather than second. Doesn't matter what order you put it in, but it's much easier to work it if you put the 2 first. So bringing 2 to the other side, I get 2 plus or minus 4. But I really can go simpler than that. What does this 2 plus or minus 4 mean? It means that we really have 2 answers. One answer is 2 plus 4, and the other answer is 2 minus 4. Remember, this plus or minus is just a shorthand way of writing one number being positive 4, one number being negative 4. It's just a quick way of writing it. Now look at when I separate it, I do the 2 plus 4, that gives me the 6. And when I do the 2 minus 4, I get the negative 2. And guess what? Here are my exact 2 answers. Look how quick this was as compared to what that we had to do over there. All we had to do was use the square root method. Take the square root of both sides, and then we can solve the equation. Obviously, I'd like to do it this method rather than this method because anything that saves me time is got to be to my advantage. Let's just I'll do one more with you, and then I'm going to give you 1 or 2 to try. I'll leave this one on so that you can see the method being used. So let's say I gave you this example. X minus 2 squared equals negative 36. Again, what I have is a binomial squared. I have something squared equaling a number. And it's a perfect setup for the square root method. Take the square root of each side. The square root of x minus 2 squared is simply x minus 2. On the other side, it's not anything squared, so I have to actually do its square root. So I do plus or minus the square root of negative 36. Remember the pattern. The side that has the square, you just remove the exponent 2. The other side, you do plus or minus the square root of. And then you simplify. Well, the square root of negative 36, we know, is 36 times negative 1, which is 6i. The square root of negative 1 is I. So actually, this gives me x minus 2 equals plus or minus 6i. And I want to get the x alone, so I'll bring the 2 to both the other side. And just like I did before, I always put the number I'm bringing over first, so that's going to be a 2 plus or minus 6i. And actually, I just leave my answer like this because 2 and 6i are not like terms. They can't be combined. So instead of writing it separately, 2 plus 6i and 2 minus 6i, it's just much more convenient to write it this way. Over here, I did separate it because I could go further. But over here, I can't go any further. This is my answer. Notice it's a matter of doing 1, 2, 3 steps. 3 quick steps. All right, here's one for you to try. I'm going to give you a few minutes to try that one. Okay, and I have this set up. Again, I have something squared equaling a number. That's my clue to use the square root method. When I have on one side an expression squared, whether it's in a parentheses or is just a single letter. I didn't call attendance yet. Okay, so don't worry, I'm going to call attendance a little later. So I have this expression, something squared equaling a number. So I know what I have to do is take the square root of both sides. Now the square root of the side that has the square on it is just what's inside that parentheses, is 2x minus 1. On the other side that's not in the square root, it is not squared, it's not something squared, then I have to do plus or minus the square root of that number. So this is my essential step for when that's called using the square root method. Now I'm just going to finish up by simplifying. First of all, I want to simplify the side that has the radical. Now 24 is not a perfect square, but I can break it down into 4 and 6. And the square root of 4 is 2. So this really becomes 2x minus 1, I'm leaving this side alone, equaling plus or minus 2 square root of 6. And now I want to get this side to be plain x. That's what I'm looking for. So the first thing I'm going to do is I'm going to add 1 to both sides, which will give me 2x equals 1 plus or minus 2 radical 6. Remember, the number that I bring from the other side always goes in the front. And we didn't have this before. We didn't have anything in front of the x. We didn't have an expression in front of the x, but now we do. We want to get x alone, we'll divide by 2. And my final answer then becomes 1 plus or minus 2 radical 6 over 2. Now be careful. This 2 can't be reduced unless it can go into both terms. If this would have been a number that's divisible by 2, I could have simplified this. But 2 doesn't go into 1, and you can only simplify a binomial over a monomial if the monomial goes into both terms. So we just leave our answer like that. All right, so that's the square root method. Let's go on a little further. The square root method is great in most circumstances in which it's usable. But it doesn't take us into, we can only use it if we have something squared equaling a number. Either just a plain x squared or some expression squared. But most examples that we have don't fit that expression. For example, what if I had this example? Y squared minus 12y minus 8 equals to 0. It's a quadratic equation. It has a square. But if I tried factoring this, the y squared would be y and y. the last term is negative means one is positive and one is negative. And I need two numbers that multiply to 8. And when I subtract them, give me 12. Well, can you think of any two numbers that when I multiply them will give me 8, but when I add them will give me 12? Well, subtract them will give me 12. Obviously not, because if I'm multiplying two numbers that are going to multiply to 8, those two numbers are each going to be less than 8. So when I subtract them, the answer I'll get has to be less than 8. It can't be 12. So here is a perfect example of where we run into problems. We have a quadratic equation and it can't be solved by factoring because it's not factorable. And I can't use the square root method because I have a trinomial. I don't just have a y squared. I have this y term as well. And therefore, I have to be able to deal with this in a different method. And the method that we used is something called completing the square. I'm going to work with this thing so that I end up with some expression squared equaling a number, because then I could use my square root method. Now, in order to do that, I better think about this a little bit. Let's just look at the variable parts. The y squared minus 12y. Now, I want to add a number to this that it's now just a binomial. I want to add a third number, a plain number to it, so it'll become a trinomial that's a perfect square binomial. And if I remember the pattern, then I'll be in good shape. Remember when I had something like x minus 5 squared? That, and the quick method of doing that would give me x squared for my first term, plus 25 for my last term. Remember, 5 times 5, negative 5 times 5. And the middle term, if you remember, was these two numbers multiplied together, which is negative 5x, doubled. It would be negative 10x. We did this before. Anytime you have a binomial squared, the first term in your answer is going to be the first term squared. The last term of your trinomial will be the last term squared. Negative 5 times negative 5 is plus 25. And the middle term is always the two numbers multiplied together and then doubled. So now I'm going to answer a question. What if I had just given you x squared minus 10x? And I'm telling you I'm missing a number. I'm missing a number that if I have that number, it'll make that trinomial a perfect square. Obviously, you know what the number is. It has to be 25 because I'm just comparing this. But how would I have gotten to that 25 without having the answer ahead of me? Well, look at it. I know that that middle term are the two numbers multiplied together and then multiplied by 2. So divide this number by 2, which will give you negative 5, and square it. Negative 5 times negative 5 is 25. And on top of that, this negative 5 is the number that goes inside the parentheses that gives you the x minus 5 squared. I'm going to do one more and then I'm going to give you one to try. Suppose I have x squared plus 8x and then I have a blank. I have two terms of my trinomial. I want this trinomial to be a perfect square so that I can write it in a parentheses. I want to write it as something squared. And I have to do something that's called completing the square. That's why this is completing the square. It's called completing the square because this is incomplete. It only has two of the terms, and I need all three. So completing it means figuring out what that third term is. Well, if I follow the pattern, what I have to do is take this x term, which is your middle term, divide it by 2, so that'll give me plus 4, and multiply that 4 by itself. In other words, square the 4. 4 times 4, that'll give me 16. The number 16 will complete the square, and then that will be the, in factored form, as a binomial squared, it will be the x plus the 4 with a square on the outside. Okay, let's see if you can do the next one. Suppose I have y squared minus 12y. What would you do to complete the square? Give me a couple of minutes to try it. Okay, let's see if we can do this together. Remember what my steps are. I only have two terms of the trinomial. I want to get the third term. What I do is I take the number in front of the x or the y, whatever the middle term is going to be, and divide it by 2. That gives me negative 6. I then take that number and multiply by 6 itself. Negative 6 times negative 6 is plus 36. The number we need to add to complete the square, to make the binomial into a trinomial that's a perfect square, we have to add 36. Half of this number squared. And now in factored form, as a binomial square, this is going to be y minus 6 squared. You notice I need that negative 6. How do I know it's negative? Whatever the sign of the middle term is, that's what the sign of the number is. Our last term always is positive. But here, since this is a plus 8, the number inside here was plus 4. Half of 8 is 4. This is negative 6. Half of negative 12. Half of negative 12 is negative 6. Okay. So now I'm going to show you how this can work in solving a problem like this. Y squared minus 12y minus 8 equals 0. This method of completing the square, this method of solving a quadratic equation that we couldn't factor, really is, it can be done in other cases, but we will only use it in 2 cases. We'll have to have 2 characteristics. Number 1, the number in front of the square term, the x squared or the y squared, has to be 1. In other words, my leading coefficient has to be 1. If it's another number, it gets very complicated with fractions. We don't want to do it with that method. Also, the number in front of the regular x or y term, the one that isn't squared, has to be an even number. In this case, we have both of those things. This is just has a leading coefficient of 1, and this term is even. What do I do to solve it? I bring, and this is something we don't do with most quadratic equations. Most quadratic equations, we want it equal to 0. But in this completing the square method, we want the plain number, the number that doesn't have any x or y. It has no variable, brought to the other side. Now, if you notice, even though I brought it to the other side, I left a space here. That space is very important because I'm going to fill it in. I'm going to fill it in with the number that completes the square on these two terms. Actually, we did that one over here. Remember, in order to complete the square, we divided this number by 2. The negative 12 divided by 2 gave us negative 6. And I squared it. Negative 6 times negative 6 gives me plus 36. 36 is what completes this binomial to make it into a perfect square trinomial. But this is an equation. I can't just add 36 to a side and not change my equation. But if whatever I add to one side, I add to the other side, then I'm maintaining my balance. This is still an equation. I added 36 on the right side, on the left side to complete the square, but since I added 36 on the left, I have to add 36 on the right as well. Now let's see what we have here. Since this now is a perfect square, I can write it in its factor form. Remember, I already have the negative 6 here. I just put the y here, put the square on the outside, and I get y minus 6 squared on this side. And on this side, I just combine the like terms. They're both numbers. 8 plus 36 is 44. And if you notice, this is just like the questions that we were doing before. I have something squared equaling a number. So I can use my square root method. Since this is a binomial squared, when I take its square root, it just gives me the y minus 6. On the other side, I do plus or minus the square root of the number, which is 44. Now, 44 is not a perfect square, but I can simplify it. This will become plus or minus the square root of 4 times the square root of 11, because 44 is 4 times 11. And the square root of 4 is 2. So it turns out that we have y minus 6 equals plus or minus 2 radical 11. And if I want to find out what y is, I now want to get the y alone. I'll add 6 to both sides. Remember that number that I bring to the other side always goes first. So my final answer comes out to be y equals 6 plus or minus 2 radical 11. These are not like terms, so I can't simplify this any further. So I can leave it with a plus or minus sign. And notice I started out with an expression that couldn't be factored. So my old methods of solving quadratic equations didn't work, but yet I was still able to solve this quadratic equation. And as a matter of fact, the answer, I would never gotten an answer with a square root if I factored, because you never get square roots when you're breaking things up. But here we were able to solve this quadratic equation using this method called completing the square. Now, should I give you one to try on your own? Or do you want me to do one more and then give you one to try? You ready to try one on your own? No response. Anybody? You want to try it on your own? Okay, then we're on our own. And let me put a problem on the board. I'll leave this over here so you can use it as a model as to what you should do. squared minus 4x equals negative 1. Okay, I want you to do completing the square on this. Okay, let's work on this together. Okay, again, if you notice, it's a quadratic equation that starts with a leading coefficient of 1, and the number in front of the x term happens to be even. So it is a good setup for using the completing the square. Now, usually my first step in completing the square is to bring over the constant term, the number that doesn't have any x on it, to the other side, but they already did this for us. So we're already set up to start completing the square. Remember what we do. We take half of our x term. The coefficient of the x term is negative 4, so half of that is negative 2, and I square it. And when I square that, I really should leave myself some room over here. Let's do this. And when I square that number, that negative 2 squared, what that gives me is negative 2 times negative 2 is plus 4. Again, half of the coefficient of the x squared. I add it to one side, I have to add it to the other side as well. And therefore, this gives me this expression, x squared minus 4x plus 4, is actually x minus 2, that binomial x minus 2 squared. Okay, what are we getting on the other side? We're getting negative 5 plus 4, which is negative 1. So now we're set up to take the square root. Now using the square root method. The square root of x minus 2 squared is x minus 2. On the other side, we have to do plus or minus the square root of the number. Well, the square root of the number is negative 1. So remember, the square root of negative 1 is I. So that means x minus 2 equals plus or minus I. The square root of negative 1 is I. And now all I have to do is bring this 2 to the other side. And that'll give me x equals 2. Remember, I always put the number first, plus or minus I. And I stop right there because these two numbers are not like terms. They can't be added. But notice my answer came out to be a complex number. It has an I in it. Okay. Let's do one more example together. We'll do it in steps. Just to remind ourselves that we know how to do this now, this completing the square method. So let's say I gave you this example. A squared plus 10a plus 22 equals 0. Okay. Let's go through the steps again. First of all, can I factor it? Well, the only way I could break up 22, it would be 2 and 11. And 2 and 11 don't add up to 10. This is not factorable. In any case, even if it was factorable, we want to use it because completing the square method. And what we do when we're using the completing the square method is first bring over any term that doesn't have the variable in it. In this case, the variable is a. So I'm going to bring the 22 to the other side. Okay, a squared plus 10a equals negative 22. Okay, I'm giving you a couple minutes. Think, what number should I add in order to complete the square? I'm giving you a couple of minutes to think about that. What number should be added over here that'll make this into a trinomial that's a perfect square? Okay, if you thought about it, remember what I told you to do. Take the number in front of the x term, or the whatever the variable is. The number that is not the square one. That the number in front of it is the 10. The coefficient of this term is 10. I divide it by 2, that gives me plus 5. And what I do with that number is I multiply it by itself. 5 times 5 gives me 25. So I have to add 25. That will make this a squared plus 10a plus 25. That is now a perfect square trinomial. Of course, what I added on this side, I add on the other side as well. And I then write this a squared plus 10a plus 25 in factored form. Remember, all I have to do is put in the a with a square, because I knew the number that goes next to the a has to be half of this number. It has to be the 5. If you don't believe it, just do a plus 5 times a plus 5. You'll see you'll get this. Okay, what are we getting on the other side? Well, we have negative 22 plus 25, which is positive 3. And now we take the square root. The square root of the side with the square just becomes the a plus 5. On the other side, we get plus or minus the square root of the number 3. In this case, it's not a rational number. 3 is not a perfect square. All we have to do is bring the 5 to the other side. And that gives me a equals negative 5 plus or minus radical 3. There's my answer. These are not like terms. They can't be combined, so we just leave it like this. Again, we're really in good shape now. Anytime we have a quadratic equation that starts with just a plain x squared, with my leading coefficient, the x squared term, coefficient is 1, and the number in front of the a term or the x term, whatever the variable is even, just use your completing the square. You're in perfect shape. You can solve it. Even if your answers come out to be i's or radicals, even though it was not factorable to start out with, we could solve it. But that doesn't take into consideration what happens if there's a number in front of the a squared, or if the number in front of the a is odd, and then when I divide by 2, I get fractions or decimals. What do I do in such a case? And I'm now going to teach you, I'm going to start this today, but we're going to continue it on next Tuesday. The most important formula that we're going to learn this term. And it's another method that we can use to solve quadratic equations. And this formula can be used with any quadratic equation. If you can factor it or not factor it, if you could use a completing square or not completing the square, or you can't do any of those methods. This formula works for every quadratic equation. It's so important that once you learn this formula, you're really supposed to be able to recite it instantly when, if I say, what's the formula? This is the most important formula. The formula looks like this. I'm sure some of you have already seen it. It's x equals negative b plus or minus the square root of b squared minus 4ac all over the whole expression over 2a. And I'm going to show you how this can be used. And as I said, I don't think we're going to have time to do that many examples, so we'll continue this doing examples next time. But I'm going to show you how this formula is used and how it can be used to solve any quadratic equation. It's called the quadratic formula. And you must memorize it for next time. You must know it so well that if I say, what's the quadratic formula? You right away start reciting it. Okay, now there's actually 3 different letters that are being used here. An A, a B, and a C. What are those A, B, and C's stand for? Well, if you write any quadratic equation, it can be written in the form of ax squared plus bx plus c equals 0. In other words, if I have the equation 2x squared plus 6x minus 1 equals 0. Here's an example. This is a quadratic equation. Every quadratic equation is going to have an x squared term, and then it might have an x term and just a plain number, but always will have an x squared term. The number in front, first of all, we put the quadratic equation in what we call standard format. That means everything on one side equaling to 0 on the other side. The number in front of the x squared is what we call a. So in this case, for this particular example, a equals 2. I'm going to do this with different color. Here's my blue. The number in front of the x term, that's what we call the b. In other words, for this particular example, b equals 6. And the number that stands alone, that doesn't have any x, it's what we call the constant term. That is what we call the c. So in this case, the c is equal to -1. Notice part of these numbers are not only the number itself, but also the sign. The c was not 1, it was -1 because this says plus c. Checking the chat because I see there are a bunch of Okay, thank you, Darren. I will do. I'll do a 10 right after I do this. Okay. So therefore, if I want to use the quadratic formula on this quadratic equation, in this formula, wherever I see an A, I'm going to put 2. Wherever I see a B, I'm going to put 6. Wherever I see a C, I'm going to put -1. In other words, a formula. It's just replace the numbers and work it out. The big thing is when you have a quadratic equation, first set it equal to 0 if it's not equal to 0, and write down what your A is for that equation, what your B is, and what your C is. And then we can solve it. Your X is going to be negative B. So it's going to be negative, here's my B. I'm going to fill it in. I'm going to fill it in with a blue. The B is 6. Plus or minus the square root. Now here again, I'm going to fill it in. It's a B squared. What I'm filling in the B is 6, because I know B is 6. Minus 4. Okay, I have an A times a C. I'm going to fill in the A. The A is red. The A is 2. And the C is -1. Notice all I'm doing is filling in numbers. And this is all over. This whole thing is over 2. And here's my A. And my A again is my red. So all I do to use this formula is figure out what the A, B, and C is, and then just fill it into the formula. And the only other thing that you have to do is simplify. Now you just have to be careful with the numbers. So let's see, be careful with these numbers. After I do this one, we'll stop here. Don't forget to look on Delta Math for homework. Next week, there'll be a test on Delta Math. But now there'll be homework and it'll be on this sort of thing. Okay, so this is -6, so that's just -6, plus or minus. Now here's where we really have to be careful. Inside the radical, there's a lot of things going on. So I have to be careful. 6 squared, well, I know that's 36. And this is -4 times 2 times -1. Now be careful, you're multiplying 3 numbers. -4 times 2 is -8. And -8 times -1 is +8. Be very careful about your numbers, and especially the signs. Now I can add this. 36 and 8 is 44. And that's over 2 times 2, which is 4. And if I want, and usually I'm really expected to do that, they want me to simplify this. So first of all, the square root of 44 could be broken up into 4 and 11. So this will become -6 plus or minus 2 radical 11 all over 4. And the only thing I want to do now is see if I can reduce this. And I see my denominator is 4. Is there any number that goes into 4 that also goes into both terms, the -6 and the 2 radical 11? And if you think about it, 2 goes into all 3 of those numbers. I have to have it go into all 3 numbers. The 2 numbers on the top and the one number on the bottom. Now, when it has to go on in the number on the top. If there's a radical or an I, the number it has to go on the number on the outside. So I'm going to divide everything by 2. This is going to be 4 divided by 2 is going to be 2. -6 divided by 2 is going to be -3. And 2 divided by 2 is 1. So in simplest form, my answer becomes -3 plus or minus, well, I don't have to write 1 radical 11. I could just write radical 11. And the whole thing over 2. And notice I have solved the quadratic equation. There was no way I would have been able to do this without the formula. So this is where we're going to continue next time. Again, look for Delta Math homework. And let me just take attendance now. Quickly. Just answer when you hear me.